On the fairing, we're proud to display artwork representing Amazon's LEO program in its signature Krypton color, along with the American flag and the Atlas and ULA logos. The Amazon LEO name is a nod to the low Earth orbit constellation that powers this network. And if you look closely, you'll notice the logo includes an aurora shaped by the letters LEO. Just below the fairing is the Centaur upper stage. This stage takes over after first stage flight, guiding the payload to its final destination in space. Recently, it was announced that ULA is partnering with NASA to offer our high-performance Centaur upper stage for the SLS, beginning with the Artemis 4 launch. ULA provided the interim cryogenic propulsion stage, or ICPS, for the successful flight of the Artemis 1 mission in 2022, and for this week's Artemis 2 mission that launched from right here in Cape Canaveral this past Wednesday. We look forward to supporting NASA's exciting and important plans to reestablish human presence on the moon. As we continue the countdown, let's take a closer look at how ULA builds the Atlas V rocket.
Engineered in Centennial, Colorado, ULA's Atlas V rocket is built in Decatur, Alabama, and launched from Cape Canaveral, Florida. Once the rocket is manufactured, it travels to Cape Canaveral on ULA's cargo ship, known as Rocket Ship. After arriving in Florida, ULA's launch operations team begins assembling the rocket. Stacking begins with lifting the 107-foot Atlas booster, powered by an RD-180 engine, onto the mobile launch platform. 5 solid rocket boosters are attached to the sides of the first stage for additional thrust and liftoff. ULA's ultra-thin stainless steel Centaur upper stage, powered by an RL-10 engine, is then lifted into position. Lastly, the payload fairing, containing the spacecraft, is lifted and mated to the Atlas V rocket. Once assembled, countdown begins, moving the rocket from the vertical integration facility to the launch pad. The trip to the pad is about 1/3 of a mile. Throughout the 20-minute trip, a payload van leads the move, providing communication to the spacecraft, followed by the ground van providing support to the rocket. The mobile launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Track mobiles at the rear power the convoy, which includes an environmental control system providing air conditioning to the payload and rocket, as well as a backup generator. Atlas arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.3 million pounds.
From tiny particles.
My day job here at ULA is radio frequency engineering, so my team owns the systems that allow the rocket to send telemetry down to mission control for monitoring during the countdown and launch. The purpose of the telemetry system is to sample and collect data from every system on the rocket using instrumentation ranging from pressure transducers and temperature sensors to the cameras that we use to capture video during the critical phases of flight. All of this data gets formatted into a common telemetry stream, and our transmitter sends it out through our antennas, through the open air, and down to our various collection stations, where it is patched through to our ULA facilities across the country for nearly instantaneous data visualization. Today's mission will deliver 29 Amazon LEO satellites to low Earth orbit, the most ever on an Atlas V LEO mission. That's 2 more than previous missions, made possible by engineering work between Amazon LEO and ULA to use additional performance from the RL-10C upper stage engine. The team also added a 4th level to the satellite dispenser system, allowing more satellites to fly on a single launch and further accelerate deployment of the constellation. Around the world, billions of people still lack access to high-speed internet. Amazon LEO is working to deliver fast, reliable internet to customers and communities beyond the reach of existing networks. Let's take a closer look. Well, I love to talk about our antennas, and I want to take a second to point out the two types of antennas that are visible on the rocket while it sits on the pad. In this shot, you will notice that there is a large rectangular plane near the boat tail, which is near the bottom of the fairing. This antenna transmits GPS position data so that the range, which is the group that is tracking our trajectory, is able to assess where the rocket is as it flies downrange. This antenna also allows the rocket to receive commands transmitted by the range to ensure the rocket follows a safe trajectory. There's also a smaller triangular antenna visible on the interstage adapter, where the booster connects to the fairing boat tail. This is one of our S-band telemetry antennas, and it transmits data from the vehicle that we are able to receive real-time on the ground. Another interesting thing about our radio frequency and telemetry configuration is that we only have one telemetry transmitter aboard this rocket, and we need to be able to transmit data both during boost phase and upper stage flight. This presents an interesting design challenge since the Centaur is enclosed entirely in the fairing and cannot transmit through its own antennas inside the fairing. We have a series of coaxial cables running from the Centaur avionics shelf to the interior of the fairing, allowing us to transmit through two separate sets of antennas depending on the stage of flight. As we get closer to the opening of our launch window, let's take a look at the weather forecast from the Space Launch Delta 45 weather officer. Today's forecast for launch is looking good. The probability of violating launch constraints is only 5%. Ground winds are 9 to 18 knots out of the southeast, and the temperature is 71 degrees Fahrenheit. The primary concern for launch today is the cumulus cloud rule. Once Atlas lifts off, viewers watching this launch from Florida and certain points to the northeast may be able to see this launch in flight. To get a closer look at this visibility map, check out @ULA Launch on social media. We remain in the planned 30-minute hold as we continue towards liftoff. In just a few moments, ULA launch conductor Scott Barney will pull the team for the final go to resume the countdown. The launch conductor oversees the team during this process, confirming that all systems are operating normally and that the countdown is proceeding as planned. A total of 28 engineers will be pulled to confirm the rocket is ready to move forward. This is the final status check of the Atlas V vehicle, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in as the team conducts the poll.
L-7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion. Go. Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HAZ gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilicals.
Go.
Environmental control systems.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
Relay safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC. Verified T0 is set for 05:46:000.
Verified.
Polling is complete, and the team is go for launch. From now until liftoff, launch conductor Scott Barney will lead the team through the final steps in today's countdown. This includes verifying propellant levels and pressures in both the booster and Centaur tanks, as well as arming the ordnance for ignition, stage separation, and flight termination. At T-1 minute, the range will confirm it is in a green condition for launch, meaning there are no constraints such as boats, aircraft, or weather, and that all tracking systems are ready. At T-25 seconds, you will hear Go Atlas, Go Centaur, Go Amazon Leo, the final status check for the rocket and payload. To help reduce the intense sound energy at liftoff, the launch pad's water deluge system activates at T-6 seconds, followed moments later by booster engine ignition. Then, after liftoff, you will hear flight commentator Corey Buckingham providing live updates as the rocket ascends into space. Today's Atlas LEO launch will mark the 5th launch of a full stack of LEO spacecraft on a ULA Atlas. Atlas also launched a LEO proto-flight in 2023 with a modified stack. ULA will fly 3 more Atlas LEO missions after LEO 5, and then Amazon spacecraft will begin launching on Vulcan rockets. The specially modified 85K Centaur 5 tank will allow Vulcan to launch even more LEO satellites with each mission. This is Atlas Mission Control at T-minus 4 minutes and 16 seconds about to release the hold. We anticipate releasing the hold in just a few minutes.
On my mark, the time will be 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed and we are go for launch at 1:46 a.m. Eastern. After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness,
Intrigue vast, an open door, exploring what we search for. Drifting past the nebulous glow, where cosmic rivers gently flow. New horizons start to form, a silent cosmic gentle storm. Through quiet dark, a distant gleam, awaking from an endless dream. Oh, the cosmos calls an ancient plea, unveiling truths for all to see. A journey deep beyond the sun, where wonders wait forever spun. Intrigue vast, an open door, exploring what we search for. Each starlight pulls a mystery untold, a story etched in patterns bold. We reach beyond the known domain to find ourselves within the rain of cosmic dust and ancient lore, forever seeking something more. In the vastness where the silent wonders glow, you turn the unknown into a guiding show. From rocket blasts to distant cosmic dreams, you paint the sky with truth, not just moonbeams. Erkan Baz, your voice becomes the beacon bright, cutting through the dark with curious light. A channel made for those who seek and yearn. With every upload, new horizons burn through lunar eclipses, meteor rain, and distant stars. You bring the edge of space right where we are. Not just facts, but wonder stitched through time. A tapestry of reason and the sublime. To every viewer who gathers night by night, you give them context, awe, and insight. Together we watch history in flight as mysteries unfold beyond our sight. Years of work, long hours, tireless.
7, 6, 5, 4, 3, we have ignition, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying another 29 satellites for Amazon Leo. These spacecraft will deliver fast, reliable internet to customers around the world.
Throttling down as expected. Completed pitch and roll program. Mach 1 rocket is now supersonic. RD-180 now throttling up now that we've passed through the max Q period of flight. We're flying down the center of the range track at 1,800 miles per hour.
You are hearing the voice of flight commentator Corey Buckingham providing launch vehicle ascent data.
RD-180 now throttling down in preparation for SRB burnout. The vehicle is now 1/2 of its liftoff weight. SRB burnout declared. RD-180 throttling up to full thrust following burnout.
This is Atlas Mission Control at L plus 1 minute and 45 seconds. We are coming up on burnout and jettison of the solid rocket boosters. These additional motors augmented the thrust at liftoff, giving Atlas an extra boost off the pad.
All engine parameters continue to look nominal. Current altitude 35 nautical miles, downrange distance 50 miles.
We are just over 2 minutes into flight. Coming up next, the Atlas V rocket will transition to closed-loop steering, meaning it will begin using real-time flight data to adjust its path. One thing many people don't realize about launch day is that these key milestones are pre-programmed into the rocket's onboard computer, known as its avionics system. While it may seem like engineers are commanding each step in real time, that work is done in advance and tested in ULA's Systems Integration Lab in Denver. On launch day, the team is focused on monitoring the data coming back from the rocket to make sure everything is performing as expected.
Now holding acceleration at 2.5 Gs in preparation for fairing jettison. Centaur reaction control system pressurizing to flight levels. The vehicle is now 1/4 of its liftoff weight. Confirmation of payload fairing jettison and CFLR deck jettison. The RD-180 is now throttling up after CFLR deck jettison. One minute to BECO, all systems performing nominally.
Flight commentator Corey Buckingham just called out confirmation of payload fairing jettison. This composite fairing protects the spacecraft as it pushes through the harshest parts of Earth's atmosphere. Coming up, we will hear callouts for cutoff of the Atlas first stage engine and separation of the booster stage, followed by ignition of ULA's Centaur second stage engine. These events occur when the first stage has escaped Earth's atmosphere, getting above the Kármán line and into space. ULA's Centaur upper stage, with the Amazon Leo satellites attached, then takes over on a trajectory to precise locations in low Earth orbit. Let's listen in as we approach these milestones.
Boost phase chilldown complete. BECO, booster engine cutoff. Confirmation of booster separation. Pre-start on fuel and locks. Ignition and full thrust. RL-10 engine is running nominally.
This is Atlas Mission Control at L plus 5 minutes and 8 seconds. We just heard flight commentator Corey Buckingham confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. We have about 12 minutes until we reach our next mission event, which is shutdown of Centaur's main engine. This morning, we've learned about rockets, satellites, and deployments, but at the heart of it all is Amazon LEO's mission, extending fast, reliable internet to customers and communities beyond the reach of existing networks. Let's take a look inside rural Montana, where staying connected can still be a daily challenge.
Out in the middle of nowhere. I love it. I love sharing it too. I like bringing people out and showing them. MPG Ranch is a 15,000 acre conservation ranch. We want to create an educational experience and let people really tie in with the land. We like to make wildlife documentaries, and we share all our wildlife cams. So if we come across a unique or a different behavior of wildlife, we love to share it. A lot of papers have been published on a lot of the findings we've found over the years. We do a lot of outreach with high school and college and give college students opportunity to do their research. I am the field tech at MPG Ranch. I maintain all the Buckeye cameras and the live streaming cameras, the internet on the ranch, make sure it's all staying connected. So we're on Indian Ridge here, and this is kind of the center front country of the ranch. We're kind of remote. We're off the beaten path here. We really didn't have anything but dial-up off some phone networks that were in really bad disrepair. So we are accessing through microwaves that go to Dean Stone, shoot down to Missoula, and all that space is rented. One camera in the chain gets knocked out, and then I lose connectivity, and then I have to run out and go fix that chain. This network took 10 years to build. It's a hard process and a lot of maintenance.
It was Grandpa's dream to get to Montana and find a way to do it. So here we are. We never left. We are in west central Montana. We're in the Blackfoot River watershed. So if you've seen the movie A River Runs Through It, that river is right along next to us here, just on the other side of this ridge. And generally, you're going to find commercial cow-calf operations in this whole valley, taking advantage of the grass and the water and the resources that are here.
We're on our 5th generation family ranch in Homeville, Montana. It was homesteaded in 1882. A lot of family history out here. We run about 1,250 mother cows, and we keep some over to 2 years and finish them and sell a grass-finished beef direct to consumer and wholesale to restaurants and grocery stores locally. Certainly we use, internet for the direct marketing business. We have an email newsletter, we have Facebook ads and posts and Instagram posts for marketing that business. Sometimes the speed gets a little bit frustrating. We don't have cell service out here, so all of our cell phones only work when we're around internet.
When our cows are out in the pasture, they're out in the field, or they're in those mountains, you don't see them. You go in and we call by voice. That's something Norwegians do. It was something my grandpa did to gather the milk cows. One thing about our ranch, because of that legacy aspect and wanting to keep the ground, it's really a poor business decision. It maintains itself, it sustains itself, but for us to pay our bills and to build a home, every single one of us has an off-ranch job. Myself, I do the maintenance, custodian, and grounds work for our local school district. My wife, she's a project manager for a health insurance company based in Boston, but she works remotely. She's on Teams all day, but that means when I go home for lunch, I can't get internet because I'll ruin her meeting. So we have to kind of balance that. Are you on a meeting right now? Can I look up something? So everybody works off the ranch to help maintain this place and keep this thing going because we don't want to lose it. It is important, it's very important. I know that's been an issue for other folks working in the valley who need better connectivity.
Hi, Don.
Hello.
How you doing?
I'm doing well.
Good. How's your shoulder feeling?
Get kind of pinches.
Okay, how about, so give me all the way to your arm, just relax it completely. Good. So I'm gonna bring you across here. I opened this practice in 2004. We're a physical therapy practice called Rejuvenate. And then we're gonna come straight. Okay, hold there, now push up against this hand. We're 60 miles away from the next closest town. So it's really important to have local health care here. In order to get core strength, you gotta overcome. You're just making people's life a lot more functional without, okay, great, being really invasive. So we're not using any medications or any type of surgery. You're just doing it all through physical medicine and education. Nice. Have a seat, which makes a big impact in their life. Great. Our internet's not very quick. We have to document on everything we do with every patient. So the upload speed we have right now is about 4 megabytes per second. And so that takes a while. And sometimes we're typing in an eval and we'll lose connectivity and lose the whole thing and have to start from the beginning. Good, your hips are in great position. If we had quicker connectivity, I could do a lot more in my day. Look quicker, search quicker, and then just keeping up with continuing education. It's frustrating when you're paying for a service and it's down, or it's so slow. So it would be great to be just more efficient in what you do. I'm always looking up research and you're still just waiting and waiting. So it would be nice to be in control of that. Yeah, I think everyone would enjoy that.
If I had internet back there in the wilderness, the potential would be huge. We could have these essentially small footprint base stations. It'd take less maintenance and we could create more of a network out in the remote areas. Oh, this would be awesome.
Having a strong telecommunications backbone is going to help, I believe, a lot of those younger generations to be able to move back and still make a living and be on these places and to keep those legacies intact and to keep that ground working.
This is Atlas Mission Control at L plus 13 minutes and 55 seconds. We have less than 5 minutes until we reach our next mission event, shutdown of Centaur's main engine. We will return with mission commentary as we approach that next milestone. During our break in commentary, we will continue to stream live animation from flight.
All engine operating parameters continue to be nominal. Current altitude 300 miles and velocity 15,200 miles per hour. Now 3 minutes remaining in the burn. As previously mentioned, there will be 10 deploy events for this mission. Each separation will be initiated with an arm command followed by a deploy command from the ULA flight computer. After each deployment occurs, there will be a roll maneuver and/or settling maneuver. Now 2 minutes to MECO. The vehicle's present position is currently over the northern Atlantic Ocean. The first SVSEP event is expected to occur over the United Kingdom area. Now 80 seconds until MECO 1. After MECO, there will be approximately a 3-minute coast as we get into the SV separation sequence. One minute to MECO.
Monsters.
30 seconds to MECO. IIP vanish. The vehicle is now orbital. PU system and open loop control going into MECO.
This is Atlas Mission Control at L plus 18 minutes and 5 seconds. We are coming up on the end of the first of 3 Centaur upper stage engine burns. Let's listen in.
The vehicle has begun its turn to the SV SEP 1 attitude. Control looks good during the turn.
We have just heard confirmation of the successful first burn. In about 2.5 minutes, we will begin the deployment sequence for 29 LEO satellites into low Earth orbit. This will take about 16.5 minutes to complete. Let's listen in as we approach deployment of the first batch.
Now 1 minute to the first of 10 deployment events. Review of the MECO 1 OPUM shows a very accurate orbit injection. Vehicle and attitude for separation. Confirmation of successful separation of the first 3 LEO satellites.
This is Atlas Mission Control at L plus 21 minutes and 20 seconds. We just heard confirmation of the first of 10 events to deploy all 29 spacecraft for Amazon's Atlas V LEO 5 mission. As we've mentioned, LEO is Amazon's low Earth orbit satellite constellation, designed to deliver fast, reliable internet to customers beyond the reach of traditional networks. The full constellation will include more than 3,000 satellites, and their altitude allows for lower latency than traditional satellite systems. Each satellite uses electric propulsion for orbit raising, maneuvering, collision avoidance, and safety orbiting at the end of its mission. They also use optical inter-satellite links, infrared lasers that transfer data between spacecraft, forming a secure network in space. To deploy the satellites, all 29 are mounted to a dispenser system attached to ULA's Centaur upper stage. Today's dispenser consists of 3 tiers of 9 satellites each, with an additional 2 satellites on the final tier, affectionately referred to by engineers as the cake topper. Once Centaur reaches the target deployment altitude, the satellites are released 3 at a time, with short pauses in between, starting with the bottom tier. During this process, ULA engineers are closely monitoring data to confirm each deployment is successful and that all systems remain healthy. We have 9 more deployments ahead, so we'll step away from commentary for now and return as we approach the final deployment. In the meantime, we will continue to show live animation of the mission.
In attitude for SEP. Confirmation of successful SVSEP2. The next deployment event will be in approximately 2 minutes. The vehicle has begun another roll maneuver. One minute until SVSEP event number 3. Roll rate is ramping down. Successful deployment of 3 more Amazon LEO satellites. That's 9 satellites separated and 20 more to go tonight. The vehicle has now switched its antenna select to the TDRS 275 asset. Now 1 minute until the 4th SBSEP event. Indication of successful deployment number 4. The vehicle has initiated a roll maneuver as expected. One minute till SBSEP event number 5. The purpose of both of these roll maneuvers and settling is to maximize the relative distance between the spacecraft prior to Amazon maneuvering their assets to their operational orbit. "20 seconds to SEP. Successful deployment of the 3 SBSEP-5 satellites. Five SBSEP events down and 5 more to go. Approximately 90 seconds until SBSEP event number 6. The vehicle is performing another roll maneuver. The reaction control system looks good. 30 seconds to the next deployment. Positive confirmation of SVSEP-6. One minute to SVSEP event 7. Three more Amazon LEO satellites deployed. That is 21 satellites deployed with 8 more still to go. The vehicle has started a roll maneuver. The present position of the vehicle is currently over Asia. We have traversed over all of Europe. The second burn today will be performed over the Indian Ocean, with the Centaur being disposed of in the Pacific Ocean. Positive indication of SVSEP-8. 1 minute, 40 seconds until the 9th SVSEP event. Maneuver complete in attitude for SVSEP-9. 3 more Amazon LEO satellites deployed successfully. One minute until the 10th and final separation event for tonight's launch. Remember that this 10th SBSEP event will be releasing only 2 satellites. "15 seconds to SEP. Good SBSEP. Now all 29 LEO satellites have been successfully separated for our Amazon customer.
This is Atlas Mission Control at L plus 37 minutes and 45 seconds. We just heard confirmation of successful deployment of Amazon's 29 LEO satellites. As we wrap up our live coverage, I want to say thank you for tuning into this morning's flight and remind you to visit ulalaunch.com, follow us on social media at ulalaunch, and just subscribe to our YouTube channel. And join us next month for another Atlas V launch for Amazon LEO. Let's take another look at liftoff.
Subscribe to our YouTube channel and turn on the notification bell. Thanks for watching. Space Googlevesaire YouTube channel.
Where fear turns into flame, a signal cuts through endless night and calls the cosmos by its name. Not just noise, not empty wonder, but truth shaped with a steady hand. Every moment built with patience, every dream carefully planned. Years don't vanish, years leave marks. Every step is earned, not free. When passion meets persistence, the universe begins to see. Gun bowls reaching higher than the sky, turning distant stars into reasons why. Space Googlevesaire, a beacon shining bright, guiding minds through the endless night. This is more than just a channel or a screen, it's a call to explore what lies unseen. Gravity bends, time unfolds, questions rise and borders fall. You don't simplify the universe, you invite us to it all. Every broadcast breaks a limit, every word expands the view, teaching us the unknown isn't fear, it's an open door to walk through. While others chase the moment spark, you chose the long and honest way, building something meant to last with every night, with every day. Ergon balls, with a vision clear and strong, turning doubt into purpose, confusion into song. Space Googlevesaire, written among the stars, a bridge between who we are and who we can be. Through science, mystery, and endless drive, you remind us curiosity's alive. Infinity is not a wall, it's a challenge to the brave, the ones who dare to ask again and refuse to stay unawakened. The universe rewards persistence, not shortcuts, not disguise, and you show us how to look up with fearless eyes. To every viewer across the world, different lands, the same deep need to understand our place in space, to follow thought instead of speed. You're not just watching, you're becoming part of something vast and real, a shared pursuit of truth and wonder that no silence can conceal. Ergun balls beyond trends and time, building meaning where stars align. Space Googlevesaire, more than a name, a legacy powered by effort and flame. Years of work, belief and mind, leaving shallow noise behind. Through the dark, through doubt, through infinity, you prove exploration starts within humanity. The signal keeps traveling long after the screen goes dark, because real dedication leaves an eternal mark. The universe listens as the lark, and answers back, and answers back, and answers back.